In this video, I will disassemble, I will sacrifice this active tank. This unit was removed from a BMW G30, it's a 5 Series, and it's a part of the SCR system. This one have a problem, one of the very common problems that you will find on this type of system about the delivery module short circuit to ground. On that car, this tank was replaced with a brand new one and the car is working perfectly, so we know for sure that the problem is here in this tank. I want to disassemble it to see if I will find the short circuit, to see if it's something repairable or not, and to better understand how the system is working. So if you are curious like me, you are in the right place and don't go anywhere. This tank will hold the urea and water mixture known as AdBlue. This pipe from here, it's a vent pipe, and this one from here, it's a filling pipe. Through here you will fill this tank. Underneath the tank, this thing from here, this big part, it's called SCR delivery module. Inside of it you will find the metering pump with associated pressure sensor, and they are replaceable. You will find two SCR fluid level sensors with one temperature sensor. The level sensors are working using ultrasound waves to measure the level from the tank, and also we'll have a heating element for the active tank heater. The only thing that it's removable from here is this cover and the pump with the pressure. So let's start with this. Okay, here we have a couple of screws. They are with T20. And now I'm able to remove this cover. This cover have a gasket, something like a sponge. Here it's a breather. This thing it's opened with the atmosphere. You can see if I'm able to push this tab inside. It's a hole with this thing from here. And this inside, if I will open it, I will find a humidity filter that won't let the water to enter in the module. This part from here is the metering pump, and you can see I can move it. This one from here is the pressure sensor. So let's remove this one. The same, all the screws inside here are with T20. A little bit of splash, and this thing from here is the pressure sensor. You can see it has some urea water mixture. Inside there is a gasket, and this is the plug with these connections. Next step, I will remove the pump. This have a screw here and two here. And this one is the pump. This is the plug with the connections. They will connect there. And these two ones from here are inlet or outlet, and vice versa. You can see I'm spinning the pump, and the liquid it's starting to come out. The pump it's equipped with a 3-phase motor, and because of that this allows the delivery of liquid in both directions. This will spin either way. This is called an orbital pump. This pump, from what I remember, I think it's capable of doing somewhere around 8 bar of pressure. It's a very powerful pump. The metering pump with the pressure sensor are controlled directly by the SCR control unit that is situated inside of the car. They are connected directly to this plug. It's an 8-pin plug. This plug will control the unit, the module. Here it's an electronic module that will control the level sensors, the temperature sensor, and the heating element, because this tank will need to be heated to prevent the urea water mixture to freeze. The temperature sensor have a bracket here that is easy removable from what I see, and this will keep in place the plug. I can bend the plug because this bracket inside there, it has 2 screws, the same T20. And this thing from here seems to be a pressure valve or a pressure regulator. Let me see, if I pull this, nothing. If I push it, nothing. Okay, this is the inlet, and here is the pressure sensor connected. Okay, I will set this aside. Okay, now I see something inside here. I think this is the heating element. I'm not sure. Also in this side the same. I have the same thing. They are connected with this bus bar. Okay. This is the control module with the sensors. So I will open it. Yeah, this thing from here have a bunch of electronics. This is a controller. This is the main plug. I think plus, minus, and signal. Here you can see a connection, maybe for the temperature sensor. Here you see a connection, maybe for the level, and here one more. Let me see if I'm able to pull this board out. Yeah, nice. We will leave this here for the moment. Next, inside here I have a couple of screws. Yeah, I told you, this one is a temperature sensor, you can see it, it's down there, these 2 pins. And these 2 pins with these 2 pins are the ultrasound level sensors. And now this case in air, you can see this is the temperature sensor, and this down here and this one are the diaphragms. It's down there, and one have remained in here. The ultrasound sensors from here are something similar to a parking sensor. They will emit ultrasounds. Inside of the tank, on top of the tank, you will have a target. The distance between the sensor and the target is calculated from the factory, and it is programmed inside of the controller. When you will add liquid inside of the tank, the ultrasound wave will need a longer period of time to travel in the liquid, and from there the controller will know exactly what is the quantity of liquid inside of the tank. And also the controller is able to see the quality of the liquid. This is very important thing, because if the mixture between the urea and water is not correct, the NOx harmful gases won't be eliminated. So because of that, you will find that error message in your instrument cluster, in your navigation, about the poor quality AdBlue detected. One, from here, And the second one, that the system will know that the AdBlue is a poor quality mixture, is from the NOx sensor from the exhaust system. So at this time, at this moment, I have removed everything that it's removable from this tank. And the only thing that I'm able to do now is to cut it open. I want to see the targets inside of the reservoir, if there are any. Maybe the target is the case of the reservoir, who knows. And I want to see the heating element, if the heating element is prone to failure or not. So from this point now, this thing will become messy. Before I will start to cut the reservoir, I have seen here these things. These are looking like some screws, but they are from plastic. You can see them. I have something that will be perfect, I think. Here, 8 mm, okay. Let me see if I'm able to... Oh yeah, they are screws. Yeah, they are metal screws with plastic head. And now I think this thing will supposed to be removed. Yeah. Nice. So in case you will break this thing, it's replaceable, but I don't think you will find to buy this separately. You'll need a donor reservoir for this part. And also there is something inside of the line I need to investigate. To cut open the reservoir, I will use this oscillating tool. Okay, and I think I will go around the world. Okay, wish me luck. Whew, very hard and noisy. Whew. I cut it all around, but I think I have some problems. You can see these marks from here. I think they are reinforcements through the entire tank. Let me try to cut them the same from here. Oh no, I think they are in an angle. Okay. Let me see where else I have seen them here. Okay. Here we're a little bit deeper. And why this thing won't open? I have a couple more here. Okay. Little by little. but I still have something that it's keeping this thing connected. Let me find a piece of wood. Okay. Okay, I have to cut this thing from here because this is connected to the other side. I will do something like that. Whew. After fighting with this thing, I was able to open it. Yay! I have some solution inside. I will remove it. And this is the inside of an active tank from a SCR system. This here is a one-way valve. Nice. This is the filler neck. This is the top of the reservoir. And I don't see any target. Okay. Now this is the bottom of the reservoir with the delivery module. This is the delivery module. The hard part was to cut this thing from here. You can see these ridges, these ones and these ones was not too hard to cut, but this one was a little bit of struggle. I think I have here, what is this? A filter. Or this is the heating element? No. This is a filter. I don't know if you see, but I already see some crystals here. Okay. Yeah, this is a filter and it's a big one. Interesting. You can see this is the inlet and all this surface, it's a big filter. Okay, so the heating element, it's something inside this plastic case, inside of the delivery module. This thing from here and this thing from here are for the ultrasound sensors, and this is the temperature sensor. And the target, let me see, this is in this position. And the target, I don't see any target. The target is somewhere around this area. I think maybe this one and this one. These are the targets for the ultrasound sensors. Okay, now I will cut out the delivery module from here to get rid of this big case. I managed to cut the delivery module from here. I will put this aside. Okay, I have cut this tunnel from here and I have found something here. So the solution will enter here from the filter, will exit through here, you can see this with this, will come here, and at this point I have, let me see if I'm able to remove it, it's a check valve with a spring, you see it? This is a check valve, because from here directly will be connected with the pump, you see? This is one way for the pump, and the second way for the pump, this here inside, it's separated by a wall inside of this thing, and from here will exit from the pump, will be connected to this hole. This hole from here is for the pressure sensor, and from here will come here, and this is the exit port for the pressure, for the high pressure, for the solution. So the way that this system is working, it's quite simple. Fresh fluid from the filter will be sucked by the pump, will be sent through the pressure sensor and directly to the port. And to go the way back is the same trajectory but in reverse. I have cut this ring from here, and now I'm able to separate this part. Is this plug, it's only for the pressure sensor and the motor, the pump. This plug from here is for the heating element here and the electronics module with the temperature sensor and the ultrasound sensors. The heating element, it's melted in this case. It's a little bit heavier. This is one of the connection. This is the second one, and here is the third one. The heating element have 3 connections. This metal bus from here, I think, is the positive. You can see it. And this one from here is the negative. The negative, I think, is a big metal ring. You can see it here, the metal. You can see it here. You can see it down there. Anywhere you can see that big shiny thing from there. It's part of the big metal case. And this is all. Something interesting here is this thing from here. Have this metal thing with a hole. Have a prism there, like a mirror, and this from here are the ultrasound sensors. Maybe together they will create a sound wave that will be sent here and up to this tube, and this is a part of a measuring. Maybe the quality of AdBlue is measured here, or the quantity, but for the quantity I don't think, or maybe it's possible, I don't know, but the other end of the reservoir or the tank, it's here at this height. Short circuit, I don't think I will find here. The error code for this problem, it's about the active tank SCR delivery module short circuit to ground. Won't tell me exactly what is shorted here. Let me try to measure the heating element. Let me see. Ohms. .8 ohms. This is a good value. Let me try to send 12 volts, 13 volts, okay? I set positive and negative. Oh, it's taking more amps that my power supply is capable, over 5 amps. Let me see if I have some heat coming out. The heating element, it seems to work. It's starting to feel the heat. I feel it here in this area, here in this area, and here in this area. Yeah, only these three areas where these elements are. Okay, so the heating element, it's okay, it's excluded from the short, but for that I will have a separate error, I am pretty sure, because that one is powered separately. Next step, the motor can be shorted, but I think I will have a separate error for that. And the only thing that can be in short, to have that short circuit, is the control unit, the main board. So to test this, I think I'm able to power it. The ground it's in the middle, plus it's in the right, and here in the left I think is the communication port, the signal. Okay, something like that. Let me see. Yes, the right pin is the power supply for sure. I have a diode here in the right. This one is the communication port. Yes, you can see it. It's coming directly from this controller. It's this pin from here. It's going in this resistor and directly outside. And let me check to see if I'm able to find something, to see something physical. Maybe a hole in some parts, but no, I don't think I'm able to see. No, I'm not seeing something unusual. So this one from here is the power supply. This will come in this capacitor to the ground, and we need to pass through this diode. 230 volts. I don't think this is a bad diode. This one have a hole here. This one have a hole. Ah, let me check this one also. This seems to be a diode. 0.73938, and in the other way 2.9 volts. Oh, okay, this one seems to be okay. Yeah, I don't see anything obvious here. Let me check this transistor from here. 0.75, 0.76, this one is good. Let me check this big one from here. 0.4, 0.6. Yeah, I don't know exactly what can be the problem. Maybe the big controller is the problem in our case. The controller have failed, who knows. Let me see if I'm able to see what type of controller is this one from here. PIC 18F26K. Okay. And this thing from here, it's a Continental U2735TA. Yeah. Now I want to remove this part from here. Like that. This is the temperature sensor. Now I will take the board, the main brain. I will put it inside here. Something like that. And now I will spread a little bit these pins, because I want to power up this module and to hook it on the oscilloscope and see if this thing is dead or not. First step, I will power up my power supply. Okay, so I have established that the middle pin is ground and this one is plus. You can see ground and plus, and the board will take 27-28 milliamps. nothing gets hot. Next step, I will power up my oscilloscope. Like that. I will take the module. I need to connect the ground probe to the ground. Something like that. And this to the signal line. I will do a short scan. And I have something here. I have a signal. Interesting. If I will remove the power supply and switch it back, I have something. Yeah, that means that the board it's working and the short circuit is something internal or it's something software related. This is the delivery module. I have managed to disassemble it entirely. Unfortunately, I didn't find the short circuit. I think it's a problem with the board, with the controller. Maybe the short circuit is physical inside of the chip, or maybe it's something software related. I'm not sure. Next step, I have disassembled the bracket. This is the bracket for the pressure sensor. If you remember, when I have removed it, the pressure sensor will be in this position here. This thing from here, this case, was riveted in this area, here and here. Inside here I have two powerful springs and this plunger. They will be something like this. And at the end of this spring of the plunger, I have this membrane, but the membrane won't open something. I'm assuming that this membrane with that spring is something related with the pressure release. When the pump will create a very high pressure, the sensor will read that pressure, the controller will see that pressure, will give the command to the pump to shut down, to shut off, and I think it's about a couple of milliseconds until the pump will shut down. The pressure will be so high that this membrane will push back that spring, and doing this will release some pressure from the sensor. Because here on the sensor, this is the inlet in the sensor. From here the liquid will travel, will make a short 45-degree turn and will go directly to the sensor. But somewhere in this area here, it's a T with this hole. Next, the metering pump. This is the metering pump. I need to cut the pump to open it. And this thing from here is the end cap with a bearing. This have a ball bearing here. Next, the middle part, this is the pump itself. I have grabbed the key. And this end from here is the electric motor. But you can see on the shaft of the electric motor I have a cam. You see it? It's wobbling. Let me show in this way. That motion will be transmitted here to this bearing. This bearing, this is a needle bearing here. If I will push out this rubber, you can see this is the body of the pump. These two here are the ports, inlet and outlet, or the other way, because this is two-way pump, and they are straight holes inside here. The liquid will enter between this rubber piece and the case. When the wobbly part will push against this rubber, will close this area against the case. And when this will move, will push the liquid until the other way. Something like this tube from here. If I will put liquid inside of this tube and I will squeeze it and I will pull my fingers like so, I will push the liquid in this tube until the liquid will exit, and behind I will create some vacuum that I will pull new liquid. This is the process that this pump is doing, something like that. And also this rubber body, you can see, have a hole, because in that hole I have this key. This key will keep the middle part against rolling, because you need to have this part stationary, and the key will enter here, like so. This is a very interesting pump. I don't know how much time this rubber will last, because from my own experience I know that the rubbery parts are not lasting very long. Now, after doing this, it will be very easy for me to better understand how the system is working, and next time when I will have a car with a system like this and I need to diagnose it, this information will help me a lot. Unfortunately, this thing is not repairable, and if you are still here, that means that I have done a great job showing you and explaining you how the system is working. So with this, I hope you learned something new in this video, because I have learned something new doing this video. If you do so, show me by hitting the like button. Thank you for watching these videos, thank you for being with me, and until next time, you know the drill, stay awesome, bye now.